Okay, I found the error rather easily. Just reviewing everything looked right. I was careless here. I get a plus lambda squared, not a minus lambda squared. And I do get a minus 5, but it should be lambda squared minus 4 lambda minus 5. And of course, lambda squared plus 4 lambda plus 5 doesn't factor as lambda plus 1 times lambda plus 4. So I was just seeing what I expected to see rather than what was there. So this would be pretty easy to adjust. Maybe a little messy, but we get then lambda minus 5 times lambda plus 1 equals 0. So lambda equals 5 or lambda equals negative 1. So everything I said here is good, but now 4 and 1 doesn't even multiply out to 5. Okay, so let's go ahead and do this for lambda equals 5. And I'm just going to kind of wipe out all this stuff because we can write it again quickly. Okay. So now we plug in lambda equals 5, and we get one minus 5, 2, 4, 3 minus 5. Yeah, that's going to work fine. Okay, so minus 4, 2, 4, negative 2. And now we have negative 4k1 plus 2k2 equals 0, and 4k1 minus 2k2 equals 0. And these equations are identical except for multiply both sides by negative 1, and they become identical. They have identical solutions. So this one implies that k2 equals 2k1, and this one implies that k2 equals 2k1. And that must be the case, because what showed me that I had an error last time was that we got two different conclusions here. Okay, so if we choose k1 equals 0, then k2 equals 2, and choose k1 equals, oh man, careless and slipper chalk. It's a grotesque looking one, so let's fix it. If k1 equals 1, then k2 equals 2, and k1, k2 equals 1, 2. Okay, now we see, well, go back to our solution. So xy equals 1, 2 e to the negative lambda t, because remember our conclusion, our assumption was that xy equals k1, k2 e to the lambda t. using K1, K2 equals 1, 2, and lambda being our eigenvalue, then this xy equal 1, 2, e to the 5t, don't have much room, hopefully this shows up. This is a solution, okay? And make sure we can see that, okay? This is a solution, and the zoom camera needs to be a little bit lower, but I believe that'll show up on the video. Okay, so in any case, we found now one solution. We find the other solution just by letting lambda equal -1. And let me back up a second. I say this is a solution. It's not the only solution. Any multiple of this is a solution. Okay, so once we've found a solution to the characteristic equation, we get a solution to the entire equation, but of course any multiple of that solution will also be a solution, which is why we could just arbitrarily choose K1 equal 1, so that K1, K2 is 1, 2. Okay. If we plug in lambda equals -1 here, we're going to get 2, 2. Okay, and we're going to get 4, 4. This tells us that K1 and K2 are going to be negatives, so that the other solution, which I'll just write down here, and I kind of leave it to you to work that out. The other solution, make sure I've got some room, other solution is I could write as 1, -1, e to the negative lambda, e to the negative t, lambda being -1, it would be e to the negative t. So again, by letting lambda equal -1 and doing this, we easily arrive at this. And again, in linear algebra you did a number of these problems, and you hopefully kind of remember how this works out, but it works out very easily. Okay, so we get this. So now we have two solutions, so we have a solution set. So starting with this equation, making this assumption, we run through the familiar steps. Hopefully they're familiar, and they become familiar very quickly. Run through these steps, and we obtain a solution set. And I don't have any board room to write that out. So I guess I'm going to stop this video and go to one more video